Okay, so this is the last part here, and it's going to be about this this formula for the sinusoidal waves. I'm just going to talk about this briefly. So these are the waves that, they have quite enough. They do have a formula, and you can calculate. And these are the waves that was around here, and they look like this, periodic waves. So they have a formula here that involves these Jacobi elliptic functions. So there's the expression for the formula here. So they're not functions you've heard of, and it's quite tricky. There's a whole lot of notes here about, there's a description here in Wikipedia about them, and there's a whole lot of notes here about how to solve them, but it's not part of this course to try and calculate, other than to know that they are the ones that arise as the periodic orbits. This formula here, it's not a hell of a lot of use, because how would you, except for perhaps the fact that some computer software has this function built in, you're still going to be eventually difficult to calculate. There is a description here about how to solve them. This is not part of the course. It takes it through here, and derives the equation in terms of these roots of a cubic equation. Okay, so these Jacobi elliptic functions are the solution of equations of the form here, where this is dx. The second derivative squared is some polynomial of degree 3. So you can imagine how these equations would arise, and people would study the properties of these equations and come up with functions that solve them. Okay. Just like you've got the first derivative is equal to, the first derivative squared is some different order polynomials. But I'm going to finish there, though that's not super important. Just a very brief description of them, and you can see that the notes are there. You can read about them if you want to.